All right, so we're going to do some examples, but first I realize that I left off the whole thing about the axis of symmetry. So this green line right here is our axis of symmetry, right? It's that line that where if we fold the parabola over that or reflect the parabola over that line, it will land on itself. So the equation of that line, hopefully you can recognize that that line is always going to go through the vertex of the parabola. So if I shift my parabola left and right, my axis of symmetry is still going through the vertex. And same thing if I shift up or down. So the equation of that line, it's going to be a vertical line, so it's going to be an equation in the form of x equals some number. And the number that's going to equal is going to be whatever the x coordinate is of that vertex. So if the vertex has an x coordinate of 2.5, then that vertical line will be x equals 2.5. So we're going to do some examples in a minute, and one of the things they talk about in there is to give the equation of the axis of symmetry. So that's the thing they're talking about, is the equation of that line. So one more thing that's going to help you graph these equations, because we're going to do, when we do this some examples, one thing you're going to have to do is graph it. So you'll have numbers in here for A, H, and K, and then you'll be asked to graph it. So there's a nice little pattern here. If you just look at this really is the graph. The red equation right now is the graph of y equals x squared, right? I've set a to be 1 and h and k are both 0. So this was really just y equals x squared. So there's a nice little pattern here that emerges that will help you graph a parabola for different values of a once you find the vertex. So the pattern here is that for the first point, starting at the vertex, you go over 1 and then up 1. And then you go over 1 and then up 3. And then over 1 and then up 1, 2, 3, 4, 5. So every time you shift over 1, when you're shifting up, it's not linear, right? You're not going over 1 up 1 and then over 1 up 1. You're going over 1 up 1 and then over 1 up 3 and then over 1 up 5. And then the next one will be over 1 up 7 and then over 1 and up 9. So they're actually growing by odd numbers. So we're going to use that fact to our advantage when we want to graph something where a isn't 1 anymore. So let's take a look at some examples then. So for the first example, we're going to look at, we want to find the vertex and the equation for the axis of symmetry for that parabola where we have y equals 2x minus 1 squared minus 3. And then we're going to talk about whether the vertex is a minimum or a maximum point, and then we're going to graph it. So let's first talk about, here's the equation. So here's the little pattern I was talking about a second ago, right? We will go over 1 up 1, then over 1 up 3, then over 1 up 5, then over 1 up 7. So we're going to use that when we go ahead and graph it. So the first thing we need to do is figure out, okay, what's h and k in this? Because remember, the vertex is really the values of h and k. So one thing that you'll notice in our sort of base equation is that. So k, you're just going to pluck right off the end. So k is the value that's stuck on the end right there. So k is negative 3. H, though, is a little bit different because there's subtraction here. So that subtraction is already there. So h is actually going to be positive 1. So because of this subtraction right here, when you take h out or put h in, it's actually going to come out or go in as the opposite of what you see in the equation. So in this case, this minus 1 here is really going to come out as a positive 1. And then a is 2. All right, so we've actually found the vertex, right? The vertex then is going to be the point 1, negative 3. And that means that our axis of symmetry, remember, axis of symmetry is the equation of this line. So it's going to be our axis of symmetry, which I'll just abbreviate AOS, is going to be the equation x equals 1, because the x value of the vertex is going to be the equation of our axis of symmetry. All right, and then we wanted to look at whether the vertex is a maximum or minimum point. So whether the vertex is a maximum or minimum is really determined by whether the parabola opens up like this or opens down like this. And we can tell just by looking at the value of a. If a is positive, it's this, and if a is negative, it's this. So our value of a is positive, so our vertex then is going to be a minimum. All right, so then the only thing we have left to do for this one is go ahead and graph it. So we know where the vertex is. So I'm just going to give this a quick sketch right here. If you've got graph paper, you can go ahead and use that. That might be better to see what's going on. But so we know that the vertex is at the point 1, -3. And then because a is equal to 2 here, so it's so important I wrote it twice. A is equal to 2, what that means is that this pattern is basically going to double. So instead of going over 1 up 1, I'm going to go over 1 up 2. And then I'm going to go over 1 up 6. So I'm taking all of these vertical changes and doubling them because A is 2. So I'm going to go over 1 up 2, right? And then I'm going to go over 1 up 6. So this is 2, and then this is 6. So again, I'm just doubling these values right here. And then that symmetry is going to create those points on the other side. So it's not the best sketch in the world, but you kind of get the idea. So that's number 1. And then for number 2, we've got 2 examples here. So for each of these, we're going to go ahead and state the values of A, H, and K, the coordinates of the vertex. So as you can see, there's some overlap between A and B. The equation of the axis of symmetry. So it's kind of the same stuff as up above. We're just not going to graph it. So if you want right now, you can go ahead and pause the video and see if you can come up with the solutions for those. So why don't you go ahead and do that, give it a pause, see if you can come up with answers, and then when you're done, come back and see how you did. All right, so here's what you should have for those answers. H here, hopefully you can see is 0 because there is nothing being added or subtracted to x before it's being squared. So that makes our vertex 0, 2. Our axis of symmetry, remember, is just x equals whatever the x coordinate of our vertex is. The parabola opens up. Anytime A is positive, the parabola will open up. And because it opens up, right, it goes this way. If it opens up, then our vertex here is going to be a minimum. And then for number 3, here are your values of A, H, and K. And then this parabola will open down because A is negative. So this one's going to be this way, so it opens down, which makes our vertex a maximum. Okay, so one last thing to talk about is if you're given an equation in standard form like this, where you have something that looks like this, right? You have ax squared plus bx plus c. So we looked at this form earlier in the year. We used that form when we did quadratic formula. All right, we talked about what a, b, and c were in the quadratic formula. If you want to take it from this form and rewrite it in this form. So both forms sort of have their use. In this form, it's very easy to tell what the y-intercept of this graph will be. I can look right at this and know that the y-intercept is just going to be -3 because at the y-intercept, the x-coordinate is 0. So that would cancel out both of these terms and you'd just be left with this. So I know right off the bat that the y-intercept of this graph is 3. So that's really helpful. But if I want to graph the rest of it, there's no real straightforward, easy way to do it here without just plugging it into your graphing calculator. But if I can rewrite this in this form, then I can tell what I can get the vertex from that, and then we've already talked about how to graph it from there. So if I want to get this to look like this, what we're really doing here is we're completing the square. So we're going to step through remembering how to do that, or refreshing how to do that. So I'm going to add 3 to both sides and get this as x squared plus 2x plus blank. So my goal here is to fill in that blank so that this thing can be written as x plus or minus something squared. So remember, we divide that middle term in half and square it. So 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. So over here I get y plus 4 equals, and now on this side, because I just completed the square, I can rewrite this as x plus 1 squared. So remember, this right here is just half of that. And because this is a positive 2, this is going to be a positive 1. And then I'm going to subtract the 4 from both sides and get x plus 1 squared minus 4. So now this is in this vertex form of our equation. So h is -1, k is -4. So now I know that my vertex is the point -1, -4. I know that A is 1, so I could go ahead and graph this. I know that when I graph it, starting from this vertex, I'm going to go over 1 up 1, over 1 up 3, over 1 up 5. I also know that my axis of symmetry is the equation x equals -1. So there's a lot more information I can get if my equation is written in this form. All right, so we're going to take a look at one that's actually a little bit more challenging here. Completing the square and rewriting the equation in this vertex form is pretty straightforward and simple. We had a lot of practice completing the square earlier. Most of you guys did really well with that. If this is a 1x squared here. So let's look at one where a isn't 1. So there are a couple of approaches you can take to this. So I'm going to show you two different ones and you can kind of pick which one you prefer. So the first step's still going to be the same here. I'm going to subtract 1 from both sides and I'm going to leave a blank here. And then over here I have 2x squared minus 8x plus blank. So remember, when you go to complete the square, you divide this term in half and square it. But before you can do that, this has to be a 1x squared. So what I'm going to do is I'm going to actually factor out that 2. So we're going to fill in this blank here by doing what we did up above. So I'm going to take -4 and divide it in half. So that gets me -2. And then I'm going to do -2, and I'm going to square -2, gets me +4 here. So you need to be really, really careful here because you didn't actually add 4 to the right-hand side. You added 8 to the right-hand side because this is now 2x squared minus 8x plus 8. So what we really added to this was an 8. So you just need to make sure that you actually add 8 to the left side. All right, and we're not going to rewrite it that way because that sort of defeats the purpose of what we were doing here. So now on the left side we have y plus 7 equals 2. And now this thing is a perfect square, so I can rewrite this as x minus 2 squared. So the -2 is coming from half of that -4. And then I can go ahead and subtract the 7 from both sides and get 2x minus 2 squared minus 7. So if I want my y-intercept, I'm going to go up here and get it from here. My y-intercept is going to be 1. And then my vertex is going to be the point +2, -7, right? I remember I take this out as the opposite of what it is, and then I just chop that off the end. Okay, so that's one way you can go about doing this. The other option is you can do this, right? I can say I'm going to subtract 1 from the beginning and get 2x squared plus 8x. And then I can divide both sides by 2. And then I'm going to fill in, I'm going to leave a blank there because I'm going to complete the square on the right side. So that gets me x squared plus, oops, sorry, that should be a minus. Minus 4x plus blank. So now I'm going to fill in the blank here. I'm going to complete the square on the right side. Whatever I put here, I'm also going to put here. So I'm going to take 4, divide it in half, 2, -2, square that, and add 4 to both sides. And then now I have over here x minus 2 squared. And then you can go ahead and add or subtract the 4 from both sides back here. And now we have y minus 1 over 2. And now I need to double everything. So if I multiply both sides by 2, that cancels. Multiply everything on the right side by 2. So now I have y minus 1 is equal to 2 times x minus 2 squared minus 8. And then add 1 to both sides. So I'm adding 1, gets me -7. So I end up in the same place. Personally, I prefer this method, but it's really, really common if you do it this way to add 4 to fill in both blanks with 4. So just be careful if you're going to do it this way on the left that you realize what you're really adding to both sides. So whatever you put here has to be multiplied by this. That's what you really added to the right side. So the other thing you might be asked is to find the x-intercepts. So remember, the x-intercepts happen when y is equal to 0. So you can go back up here and try to factor this. You could run it through the quadratic formula. But really, we've kind of, because one option is to complete the square to solve, and we've kind of already done that here. So if I want to know what the x-intercepts are, I'm just going to say, all right, well, that happens when y is 0. So now I'm going to kind of undo some of these things to solve for x. So I'm going to add 7 to both sides and get this. And then I'm going to divide by 2 on both sides, so I get this. So what I'm going to do here is I'm going to get this down to a point where I can just take the square root of both sides. So now I can take the square root of both sides, and I'm going to get plus or minus the square root of 7 over 2 equals x minus 2. And then I can go ahead and just add 2 to both sides. So my x-intercepts then are 2 plus or minus the square root of 7 over 2. So these should kind of look familiar to you, and it's fine with me for right now if you leave your answer that way.